Good afternoon, everyone. Peter Grant and I are going to talk for about half an hour on this topic, understanding future energy demand. Please insert any questions in the Q&A function as we go along so that we can pick them up reasonably efficiently and use them in the question and answer session at the end. So I'm going to kick off by rehearsing the fundamental reasons for a revolution in energy production and demand. Then Peter's going to give the meat of the talk by talking about the sorts of technological changes and the economic background that we're going to need in order to be able to get to change. And then I will go on to chair a discussion session at the end. So I'm a geologist, and so I'll speak as a geologist. We know that the tempo of major long-term climate change over the last few million years of Earth history has been driven by predictable variations in the Earth's orbit around the sun. But the magnitude of these changes have largely been determined by changes in the atmospheric composition, particularly the concentration of carbon dioxide acting as a greenhouse gas. The present rate of increase of atmospheric carbon dioxide and of the associated warming is about 100 times faster than at the last major natural warming the Earth experienced at the end of the last ice age, and also predecessor events of a similar type. So why is that? Why are things much quicker now? Simply because for natural warming events, the oceans must first warm in order to release the CO2 that eventually amplifies warming, with a time lag of about 500 to 700 years. Whilst for the current human-driven warming event, we inject carbon dioxide directly into the atmosphere, so the effect is instantaneous. This high rate of change also means that the relatively slow processes by which the Earth's chemistry and biology adapt to change are bypassed, such that the Earth system's chemosphere and biosphere are increasingly disequilibrated from the global thermal state, with potentially immensely damaging consequences for human societies and economies. Although we've known these things for 40 to 50 years, and the scientific evidence gets stronger, as shown by this week's publication of the latest IPCC report, there's been much talk and many targets, but little or no effective action. The demands of technology-driven growth have continued to increase carbon emissions, whilst the likelihood of remaining within the 1.5 degrees Celsius envelope targeted at the 2016 Paris Climate Summit diminishes with every year of inaction and now seems highly unlikely to be achieved. Short-term economic interests have invariably trumped longer-term thinking and care for the next generation. So why is that? Well, perhaps humanity is hardwired for the short term. Perhaps it's the nature of politics, the desire to please in the short term and setting aside long-term consequences. Perhaps it's because the scientific view challenges the intuitive, and perhaps it's just cheating. Let the other guys take the pain and you benefit from their action and your inaction. Just as we knew that the pandemic was coming and did little or nothing to prepare for it, so it's been with climate change. But perhaps 2021 might prove to be a social and political tipping point that exposes the grim realities to citizens, to politicians, and to the big global polluters, that damaging climate change isn't just about the future, but that it's arrived. COP26 has got to be a vital springboard for action rather than simply yet another series of words. In addition, if net zero emissions are to be the target, calculated on the basis not only of emission reduction, but also of carbon sinks, we have to make sure that the assumed sinks, carbon capture and storage, forestry, or other geoengineering efforts actually can work, and that we don't go easy on emission reduction because of postulated but unproven sinks. It's beginning to appear, for example, that a massive expansion onto global agricultural land would be necessary to achieve the forest sinks that have been calculated to be necessary. So the devil does lurk in the detail, and the detail is scientific and technological. If we're to get action, governments need to plan for the details and to send clear policy and economic signals to businesses, to researchers, and to societies in ways that both speak to their concerns and mobilize their capacities by creating actionable roadmaps for public and private sectors that are coherent, that are comprehensive, and that are comprehensible to all. So Peter's now going to do the easy task of exploring some of the essential issues that need to be addressed in such a roadmap if we are seriously to address the massive task of redesigning the UK energy industry, bearing in mind the consequential personal, social, and economic adaptations that will be required. So, Peter, over to you.
Thank you very much, Geoffrey, for saying that introduction. Here's my first slide, which is taken from the Climate Change Committee report. And this shows from 1990 to 2018 how we've made a major reduction in the carbon dioxide greenhouse gas emissions. And that's predominantly because we've phased out generating electricity from coal. But as we move forward from 2018 to 2050, it's much more difficult for us now to reduce all the way down to zero. And this is the challenge that we have, and that we've made certain progress up till now, but we've got to make an enormous amount of progress over the next 29 or 30 years. This discusses some of the challenging sources that we have of CO2. First of all, agriculture. Agriculture accounts for 80% of our global carbon emissions. And because we need agriculture to feed ourselves, it must reduce its carbon impact, but it can never be carbon zero. So we have to do something to offset the carbon that's generated within agriculture. The other two really difficult issues are the production of cement, which we use an awful lot for buildings and construction, and also long-haul aviation can never be fully decarbonised. Because in aviation, it's long-haul aviation, the fuel we require for these inevitably results in carbon dioxide being emitted. So if we realise that there are these three issues, these three problems we have, then we need either to do some scrubbing of CO2 from the atmosphere or some tree planting. But tree planting is very limited because we can't cover all the agricultural land in the UK with trees, because then there'd be no space left for growing crops. The other thing that we must consider when we're talking about this is we cannot ignore the carbon that's in our imported goods, our clothes, our products, etc. The next slide talks a little bit about energy and heating. So if I look at energy in total, in the current UK energy, 43% is for heating and for industry, 40% of the energy goes into transport, and 17% goes into generating electricity. The second bullet point gives you one of the statistics. Domestic central heating boilers generate more greenhouse gases than all the UK cars put together. Now, heating and industrial use of gas consumes 5 times the energy compared to all generated electricity. And 80% of natural gas is actually being used for heating and by industry. So we have to have a method of reducing the amount of gas that we consume, as I'll show you in a future slide. And in general, as we move forward from now to 2050, we have to expect there's a very large increase in electricity use. And the reports predict it's going to increase from 17% in 2009 to over 50% of our overall energy demand by 2050. So our life in 2050 is going to be much more driven or powered by electricity. You've probably all heard or read a little bit about domestic heat pumps, which are one of the possible solutions for heating your home. there are two types of heat pumps. You can either have an air source design, where there are fans drawing air into your house from outside, or you can have it from within the ground. In other words, they drill first of all into the ground, and then you extract the heat from underground. That has the benefit that has less noise because that's a silent system. Now, if you have a heat pump system, you have to recognise that the water is not going to be as hot as you get from a central heating boiler. And this may well require much larger radiators and much larger piping in your house if you move to a heat pump system. So generally speaking, the microbore systems that some of us have with the very, very narrow pipes have got to be upgraded. The heat pump works essentially it's the reverse of a refrigerator. And generally speaking, it's driven by electricity, and you get 5 times the heat output for the electricity that the system consumes. Installation costs for these heat pump systems vary probably from about £10,000 to £40,000 for an installation, and they can be installed in about half of the domestic premises. At the end of the day, the running cost for a heat pump system is somewhat similar to a gas boiler, because you're replacing the use of gas with electricity, but of course it is carbon dioxide free. That's the benefit of heating your house with one of these type of systems. The next slide gives you some recommendations for the Climate Change Committee. The Climate Change Committee has stated that over 2020 to 2050, the demand for oil must fall by 85% and by 70% for natural gas to meet our carbon targets. They believe that petroleum use must be restricted to only for aviation fuel production. Natural gas must focus on power generation with the carbon captured and stored, which I'll go on to explain to you shortly. We expect gas will still be used in industrial processes, but it must be phased out for heating buildings. We have to have a big reduction in the use that we have of gas for heating our buildings. This talks a bit about future electricity demand. And so we're expecting the overall demand for electricity will increase by 50% to 2035 and more than double by 2050. So this means we've got to have a big increase in the electricity generation plants, the wind power systems and other that we've got in this country, and also in the network that delivers the electricity to our homes. Now, and some of the major uses of electricity will be for electric vehicles, and also if we're going to produce hydrogen by electrolysis, the so-called green hydrogen, this will drive additional electricity demand. If you purchase an electric vehicle, you should expect charging at home is going to double your current electricity bill, because you're going to double the amount of electricity you use. Another point is that intermittent renewables such as wind power and wave power, must scale up to provide 60% of our electricity generation capacity. One of the main issues with the renewables is they're not available 24/7. So we have to have some method of providing electricity when the wind doesn't blow or the sun is not shining in these systems. And there are various options we have on that. One of it can be still be generated from gas, but we have to have the carbon stored, or we may have to use expansion in nuclear generation, because these would ultimately be carbon-free systems. The little diagram on the right is from the European Union, from Energy Post in the EU, and it shows an increase in electricity beyond 2018 of more like 4 times. So we have to be ready to expect a large increase in our electricity demand. So the next slide talks about one of the technologies that we're going to have to consider. And this is what's called carbon capture, use and sequestration, or CCUS. Today, 40% of electricity is generated from gas. And so we must now capture the carbon that comes out of these plants so we can achieve and move towards net zero. Now, we only have carbon capture pilot plants at the moment, but we've got no full-scale installations. The Department for Business, Energy and Industrial Strategy, it's the government department, plans by 2030 one full-scale carbon capture installation, and they describe it, their reports describe it with a commercial framework for future CCUS installations. But this is not going to be fast enough. We need a much faster rollout of this new technology if we are to get down to zero carbon. But it doesn't come with zero cost. The extra fuel we require for the carbon capture system, the ultimate storage that we have to have possibly in the North Sea, in the depleted oil wells, will increase the cost of electricity that's generated on this system by anything, various predictions, they range generally from 50% to 100%. And I should say at this stage that Peterhead gas-powered electricity generator is currently predicted to have a carbon capture system installed by 2026, but it's been delayed several times. But that's something that we're working on in Scotland. So if I move on to the next slide, and a fuel that's going to be very important in the future is hydrogen. Hydrogen is a much more appropriate fuel for buses, large lorries and ships, etc. It's not going to be realistic for an HGV, a heavy goods vehicle, to try and be driven by batteries as an electric vehicle. The reason is that the batteries are going to be terribly heavy if you have to have enough power to power a large vehicle. And also, lorry drivers are not going to be able to wait for the length of time that it takes to recharge these batteries. So we have to think of a different power source. So we're predicting, the government is predicting, the Royal Society is predicting by 2050 a hydrogen economy, which will be comparable in size to our 2020 current today's electricity use. There are various ways of making hydrogen. We can make it from gas. That is what is called blue hydrogen, but we have to use carbon capture and storage to capture the carbon and to make it carbon free. Or we could also use surplus nighttime electricity from wind farms, for example, when the wind's blowing, because then there's excess electricity. And so we could use that to generate hydrogen. The current thoughts are that hydrogen use will be 10% in vehicles, maybe 10% in aviation, 15% in heating, 15% in power generation, and also by industry. And a major part of it, quarter of it, will go towards shipping, because hydrogen is seen as a possible, hydrogen or ammonia is seen as a possible fuel for powering ships in the future if we're to avoid them having these emissions. Now, hydrogen is not new. If you think back to when we used to have coal gas in our houses in the 1960s, 50% of coal gas came from hydrogen. You all know that Hinkley Point is being built as to be the next major nuclear installation. Now, this Hinkley Point as an installation is going to be very expensive, and there are alternatives to that. And so one of the alternatives is the design of what's called a nuclear small modular reactor, sometimes referred to as an SMR. An SMR is not as expensive to produce, to install, and it can generate 13% of the Hinkley C power output for only 8% of the installed cost. So this building a number of these small nuclear power stations can be very cost effective. The output from one of these installations could power a city such as Leeds or Sheffield. And the current predictions are that it will be able to generate electricity to 4 to 5 pence per kilowatt hour. That includes decommissioning over the 60-year lifespan of the plant. This is more expensive than some methods of generating electricity, but it's very convenient because these systems would be available 24/7. And they could be used to overcome the intermittency of renewables and they can also be used to make hydrogen. And there's an enormous possibility of these systems because the UK could actually become a country that was developing small modular reactors, and then we could therefore generate significant export potential in designing these and building these systems and doing them for other countries. Now, these systems are actually not terribly large. They're only about the size of 1.5 football pitches, so they're much smaller than a wind farm or a solar farm. And actually, they're built mostly in a factory, and then they're installed on site. So this is a new technology that is only at the design stage, but it's been carefully assessed, and they look to be a very good future solution to achieving our energy systems. One of the issues that we have is that the government needs to very urgently produce a costed roadmap or a detailed plan for the UK to achieve net zero. This plan has been promised for some time, in November 2019, in August 2020, but it's never been delivered. And the plan must tell us exactly which of these solutions that the government wants us to adopt, and then to encourage us along this road. Now, we consider that government financial support will be required to develop these carbon capture and storage systems and to find the best home heating solution. Is it to be heat pumps, or are we going to pump hydrogen to houses for home heating, or for example, are we going to heat the house directly by electricity? On the other hand, industry needs to be encouraged to scale up its work on carbon capture and storage. It needs to scale up its work on nuclear small modular reactors and scale up on the production of hydrogen, because these are all things that we need, these are all issues that we need to be moving forward on, and industry needs to be encouraged more to do some of the engineering that's required for these systems. Now, one of the things that we've seen in some of the reports is that the annualized resource cost estimate to lower our emissions to zero carbon is only going to cost us 1% of gross domestic product each year out to 2050. This is what's predicted in the Climate Change Committee's 6 carbon budget pathway to net zero. One of the things we have to ask is, do you believe that it's going to be achieved for this small a percentage of our gross domestic product? And finally, what I'd like to say is, certain things need to be done by government, certain things need to be done by industry, but individuals will need to be encouraged to modify their behaviour. For example, we should possibly be eating less meat, we should be trying to minimise our long-distance airline travel, and we should be phasing out the use of plastics, which are heavily dependent upon oil. So that's what I wanted to. These are some of the engineering issues that we need to be considering to achieve net zero, and we don't want to spend too long talking. We'd like to move over to you, to the people that are on the call, and we'd like to move and ask them what questions do they have for us. And Geoffrey is going to lead this part of the discussion.
So these are some questions that Peter and I put out. Some of them, the first 4, I think, are relatively detailed in relation to the potential of technology. The 5th one, how do we properly cost CO2 in manufacturing and imported goods and products? That's obviously going to be a major issue for COP26. And of course, the final one, about public buy-in, crucial political as well as economic issues. So if anyone wants to refer to any of those questions, we're happy to pick them up. But let's look at the Q&A first. So there's one from Norrie McPhail about ocean management, which perhaps I can pick up, that ocean management produces 70% of our oxygen and absorbs huge amounts of CO2 and can do so much more rapidly. Well, first of all, the idea of ocean management poses a very big question. How do we manage the oceans? And really one should precede that by saying, how much do we understand the oceans? And the answer is to some degree, but by no means all. I think one thing we do know is that prior to the Industrial Revolution, the oceans were a source of CO2 to a large degree. Subsequently, largely because of the increase of atmospheric concentrations and pressure of CO2, they've become a sink for CO2. We used to think that they absorbed, I think, about a quarter of the annual human production of CO2, but it now seems that it's significantly more than that. Typically, I think we used to think it was about 2 billion tons per year that were absorbed. Now we think it's probably between 0.8 and 0.9 additional billion tons. That's still far short of the total emission. One of the problems, of course, is that we are beginning to see evidence that the circulation of the ocean system may be slowing down. And if that happens, that will have a significant impact on the capacity of the oceans to absorb CO2. One scenario is it could significantly reduce the ocean sink, which would put our predicament, which would make the human predicament rather larger. So it's an important and crucial issue. Really, I think we need to understand the oceans to a much greater degree so that we can look forward over 30, 40 years to ask the question, to what extent can we depend upon the oceans as continuing to be, and possibly even an increased sink for CO2. And I should go back, of course, early on, many of you will have noticed that Peter said that 80% of CO2 is produced by agriculture. Of course, he meant to say 8%. Sorry, Peter. And then a question for Peter, again from Norrie. For heat pumps to be economic, the fabric of the buildings must be attended to first, which also reduces heat loss. Are you able to comment on that, Peter?
Yes, but that's correct. Obviously, heat pumps will work better in more modern housing, where they already have very good insulation. It's going to be quite difficult to increase the insulation in older properties, such as Victorian properties. It is possible, but I think that will add further to the cost. But I think one of the big issues with heat pumps is you require quite large radiators and quite large pipes to get the water out through the house, and so that's something that you ought to think about before you sign up for a heat pump system to make sure you're actually going to get sufficient heat out of it. It may be that you can also top it up with infrared heaters, for example, particularly in the rooms that you're living in.
Then Joseph Weston asked the question about the Rethink X energy report, which concludes that falling costs for solar, wind, and battery power mean that they're already cheaper than gas generation in many parts of the world. And is it not therefore irresponsible to dedicate resources to unproven and more expensive carbon capture technologies and expensive nuclear when we can meet our energy needs with existing renewables? Peter, do you want to have a go at that?
Yeah. The reply to Joseph is, if you think of the large wind turbines that are placed offshore, today, if you want to have a battery to back up that for 12 hours, the cost of the battery is 1.5 times the cost of each wind turbine. So therefore, if you have a wind turbine farm with maybe 50 wind turbines, that's going to be a very large battery. And at today's cost, it's going to cost more than the installation of all the wind turbines. And I agree that the battery cost will come down, but the question is how fast is it going to come down? And 12 hours is not terribly long to have as a backup for an intermittent renewable. So yes, things will change over time, but I think we need to have a solution. We need to start with a roadmap, and as technologies evolve, we can change the roadmap and adjust the roadmap. But without a roadmap, we're not really in a very good position. And this is our thought, that we need to start with a roadmap, and then we can change that as time goes on and things develop and change.
I mean, I think that last point from Peter is really a crucially important one in terms of strategy. You know, if you say, for example, you believe that in 5 years' time this or that will be possible, what happens when it's not possible if the belief that it's going to happen has meant you've done nothing in between times? So the crucial thing, I think, is to get moving, but actually to be aware that your strategy must be flexible, because as technology changes, prices and costs change, then you're going to have to adapt to those changes, which is one of the reasons why their uncertainties are large. But particularly when there are large uncertainties, you do need to go planning. I can't remember who it was. It was some famous military person who commented that plans are useless, but planning is essential. I think what we're arguing for here is planning, even though your hoped for outcomes might, in the long term, prove to be unrealizable. So there's one about SMRs, about nuclear waste. I'm probably best capable of dealing with the nuclear waste ones. I'm a geologist, have been involved without any financial benefit, I would say, in the nuclear waste business in the past. In my view, the nuclear waste issue is soluble. It's been soluble for decades. The thing that's held us at bay is somehow the priority that some have given to demolishing the potential for deep disposal of nuclear waste in order to avoid developing more nuclear production. I don't think there is a nuclear waste problem personally, but that's we could go into that at some great step. I mean, the amount of research that's gone into the deep disposal of nuclear waste is enormous. And I'd be very confident that with proper regulation, and regulation, of course, is vital. And the question is, can you trust the regulators? And it depends where you are. Then I think the nuclear waste, deep disposal of nuclear waste is a tractable enterprise. And then from Douglas Boyce, Peter, probably best for you. How will the national grid cope with additional demand? Will the electric national grid cope with demand?
Well, that's a big issue, because we're going to have a much larger grid to cope to get the electricity out from the generating stations to the users. Because as a user with an electric car, you know, you're going to require more electricity. And if you're not allowed to use gas and you have to heat a significant part of your house with electricity, then that's also going to increase your demand for electricity. And so yes, we will have to have a much larger grid, and the grid will have to be expanded year on year as the additional generators come on stream. So I think that's inevitable. There has to be a major increase in the grid to cope with transporting the electricity from the generators to the users.
Yeah. And then another one, I think, for you, Peter, from Ian Ross: green or blue hydrogen. Does it make sense to continue to dig up fossil fuels to generate hydrogen with CCS back into the ground? Does it?
Well, Ian, the other answer is we could generate the hydrogen from the SMR, from the small nuclear reactors. If you want to say we shouldn't be using gas to make blue hydrogen, it's better to have green hydrogen from electricity, then the answer is the SMRs could generate the electricity. We could use the SMRs, or we could use wind farms at night when there's a smaller demand for electricity, and that would allow us to make the hydrogen. But we're going to need a convenient fuel, particularly for ships and large vehicles, that we can store on these vehicles and then use for the transfer for powering them. So it's hydrogen or ammonia does seem at the present moment to be the best solution.
And then from Paul Bentley, why is it that there's so little discussion about reducing consumption of meat? Cows, etc., take up so much land, so much more water and feed, whereas eating a plant-based diet is much more efficient and produces far less carbon dioxide. Now, first of all, I'd take I wonder whether your first statement is correct. It seems to me that recently there has been a much greater discussion about the potential for reduction of meat eating. But I think isn't the large problem here is how do we go about getting large-scale social consent to a process which is cumulative based on what we individually do with our diets. So it seems to me the big players are you and me and others like us, fellow citizens, but also, of course, the agrochemical industries. How one sees one's way through both the large-scale political problem of major financial interests in industry on the one hand, and the feeling on the other that how can my change of diet really influence something so major as global climate? I think the social science input here is quite crucial, but it seems to me that it's one of those other issues where we need real political leadership. And at the same time, that leadership has somehow got to be global. There's got to be some sort of global consensus. Peter, do you want to comment?
No, I think that I really can't comment further, Geoffrey, on that one. I think that we know that we must eat less meat and use more plant-based diets. But then how do we persuade the individuals that that's what they should be doing? That's the question. And you probably got to do that by the cost of things or by taxation, which comes down into Norrie MacPhail's question. It says, how do we manage our lives in such a way as to reduce our energy consumption? Well, I think the only way to do that is by taxing energy or by costing energy in such a way that people are forced to make a decision as to how much energy they wish to use. But until we do that, then we just got the current system.
Yeah. I mean, one could say, of course, that the elephant in the room has been in the room for 40 years. Remember, 40 years ago, the idea of carbon tax was felt by economists in some form to be the only real means of getting a driver into economies that would change behavior. And still we're talking in ways that seem to avoid that reality. I mean, some of you will be familiar with the work that Partha Gupta has produced in recent years about how to internalize the environmental costs. And of course, we have a ludicrous situation where we believe that there is an entity called the human economy, which is a bubble in which the only actors are human actors, whereas I suspect that most of us on this call might realize the human economy is an intrinsic part of a planetary economy, an inescapable part, and yet somehow our economic system doesn't recognize that. And something like carbon taxation, it seems to me, still remains on the table as a crucial one. And the extent to which COP26 is able to make progress in that area, I suspect will be vital to determining whether any progress will be made at all. So going on, thanks for an anonymous attendee who took my quote and recognizes that it was Eisenhower. Then from Bill Nickel, do you agree that the siting of generation near large users would reduce grid costs? The home heating could be carried out by community systems, delivering savings of scale.
Yes, that's correct. These are both correct. But the trouble is that a lot of the generators are placed near the sea and everybody doesn't live by the sea. That's one that's one of the issues, because if you site the generator near the sea, you get a large amount of cooling water, and so that's why many of the generators are around about the sea. Home heating could be carried out by community or local systems, yes. But then you have to be somewhere close to the generator so you can use the excess heat from the generator to heat the houses.
Mm-hmm. Can I pick something up there, Peter? I remember some years ago, one of the big ideas was a European supergrid, probably extending into North Africa, such that the problem of intermittency could be solved because the wind is always blowing somewhere and the sun is always shining somewhere. on average, that's the case. And to some degree, that seems to have gone onto a back burner. And I wonder whether part of that comes from a consequence of a perceived increased political instability, which makes very, very large-scale systems like that to be rather vulnerable. I mean, has it really gone onto the back burner, Peter?
I think it has, Geoffrey, yes.
Oh, that was a simple answer. Thank you. Thank you for that. So, Kenny Taylor, what's the future of large-scale hydro and pumped hydro?
Hydro is quite modest in terms of its output. So one typical pumped hydro schemes would be Cruachan in Scotland or Dinorwic in Wales. Now, Dinorwic in Wales is a much larger system than Cruachan in Scotland, but the amount of energy that's stored is actually quite small compared with what comes out of a large wind farm. And so you would have, if you want to try and use these as the backups, you would have to have hundreds of hydro and pumped hydro schemes. It's not as though you can get away with 5 or 10, because the output in terms of megawatts generated and megawatt hours that are stored is actually quite small compared to the overall electricity system.
And my presumption would be too that increased large-scale hydro would meet much greater resistance than has the spread of wind farms over the countryside. So then something from Katarzyna Piakaszka: can the nuclear waste be reused somehow, or just store somewhere in Fukushima after the tsunami after the tsunami destroyed the place where it was stirred? That's very dangerous to oceans. Well, first of all, it's worth saying, of course, that the UK was planning to go down the route of utilizing separated plutonium as a fuel that could be regenerated time and again, and in principle would have been a very efficient way of generating electricity. The French do that to a degree, but in practice, many of the obstacles of that have come from the perception of safety. I mean, I chaired a Royal Society report some years ago, which strongly criticized the UK government, because at that time, actually we still do, have over 100 tons of highly refined separated plutonium, which is a hazard of with extraordinary potential for damage. So let's go down. Joseph Weston suggests tax industrial livestock production. Why not? I mean, I think the tax element is crucial in all this. Tax is a key driver of behaviour. And then from Brendan Hill, demand can also be reduced legislatively and made mandatory. Far better insulation of homes, smaller and lighter vehicles for urban mobility.
I think Brendan's correct, but of course, as you notice, if you think back to the first Mini, the British Leyland or the Austin or the Morris Mini, it was a very small car. Look at the Mini today, and look at all the people that drive around towns in SUVs. So a lot of vehicles have got much larger, much heavier, and so when they become electric vehicles, they require big, heavy batteries. The only way to overcome that would be legislation and tax on the cost of these heavier vehicles and tax on the fuel that they use to drive them. So again, I think we come back to having a legislative solution for this to make sure that things are managed more fairly or more fairly.
Yeah, and then Colin Baird comments on the efficiency of modern nuclear plants, SMRs in particular, which might also enable us to deal with the waste and manage the waste more effectively. I mean, I think Peter's comment that one SMR could power Leeds. We might even think of going back to the old, analogous to the old regime of town gas, where a city to a degree was responsible for its own power production. One of the advantages of that, in a sense, is that also those people who use the energy also have to deal with the waste. which arguably is the right way to do things. You know, the energy generators and energy users ought also to be those responsible for disposing the waste, provided that it's done according to appropriate regulations. It's a much more democratic and responsible and accountable system. And then Ronald McQuaid, methane is also crucial for global warming. What are main implications for example, hydrogen production and other policies on methane levels? I mean, perhaps I could comment first of all, of course, there are large natural sinks of methane. I mean, you will know about the permafrost in Siberia. There are also many of the world's continental shelves underlain by solid methane deposits, which, if they were to materialize as gas, would create profound problems. So there's a major issue of the potential release of natural methane in a warmer world. But then, of course, there's the methane that might be produced as a part of the process of hydrogen production. Do you want to comment on that, Peter?
No, I think you've covered that. So I'm not an expert on methane.
Mm-hmm. But of course, I guess we all know that methane is a rather nasty one. I mean, as a greenhouse gas, it has something like 40 times the potential of carbon dioxide. And then from Laura Fleming, economies are currently built on globalization and lowest cost in financial terms. Do you agree that in order to meet the challenge of carbon neutrality, we need to revert to localized production of energy, food, etc., something that I discussed briefly a few moments ago? I totally agree that carbon taxing will be crucial to pricing the environmental cost of producing and consuming carbon. Energy is a finite resource. I mean, I think there is an increasing view. It's a global view too, amongst economists and many politicians, and that is somehow that we have to rein in a particular sort of globalization. That human values have got to play a much greater role. Indeed, the recently retired governor of the Bank of England recently produced a book making this point very, very strongly. We really must insert into economic procedure human values. So, from Colin Bird, what?
Yes, I'll answer Colin Bird's one. But biomass is important, but biomass is going to be actually quite a modest contributor to the overall demand for electricity. I believe it's probably not going to be more than maybe 5%, because we're talking about very large increases in requirements for electrical energy. Now, when you're talking about biomass, Colin, you've got to be very careful, because if you're talking about burning wood pellets, then that's not a very sensible thing to do, and it generates a lot of CO2. So yes, biomass will play a small part, but it has to be the correct type of biomass, because otherwise we're not achieving a reduction in CO2.
And then from Ian McKenney about tidal power.
Geoffrey, tidal power is very important, but and there's a lot of energy, for example, in the Solway Firth, potential energy that could be extracted by tidal power. But the marine environment is a very difficult environment to work in. It's difficult to build the turbines and to keep them working in salt water. So that's one issue. And also, you're generating the energy an awfully long way from where it's actually being required. For example, in the central belt of Scotland. So that would need an awful lot more transmission capacity to get it across. But yes, that's very important, tidal power, and a lot of people are working on tidal power and trying to build better tidal turbines, both more efficient and ones that are going to be able to stand up to the marine environment. So yes, I expect we're going to see a mix of wind and tidal as we move forward, and possibly more tidal, a bigger proportion of tidal as time goes on.
And then from Bill Nicol, let me read this one, Peter. I was just thinking of the peak load charging for electricity that would give an incentive to have a less inductive load. Would it be possible to have a time of day version to smooth out peak demand? So, yes, that
is an option. that we could use. I mean, it's used in certain parts of the world. I mean, in California, they switch off your air conditioning when there's a peak demand for electricity, so it doesn't exceed the generation capacity, and that's something that's all done remotely. So instead of increasing the cost, they basically switch off some of the equipment. Yep. So peak charging is also an important factor, but I don't think it's been adequately considered in the UK up till now.
So to the anonymous attendee asking about recording, yes, the Society will attempt to make this recording available
after the event.
Then from Paul Bentley wants to go back to his early comment about plant-based diet, and that relates to the generation of methane by cows, sheep, and others. And yes, of course, it is actually a significant contribution to that to methane generation. And then to Katarzyna Piekarska, I hope I got your name right. Building and construction produce a lot of CO2. She's found out that UK doesn't have all the factories for typical materials, some of the products in the EU. There are very few factories that produce recyclable materials. Brexit is forcing UK to deal with that. Local products, recyclable, would do a good job. I mean, in a sense, that asks a larger question, and that is our economies, which have become globalized, so that you and I now, depending on, unless we're very fastidious, eat and drink things that have come halfway across the world and are clothed by them too. Ultimately, is that sensible? I mean, ought there to be some sort of scheme, possibly a tax-based scheme, where one taxes large-scale transport of materials? And in a sense, that comes back to the first question that we asked, or no, sorry, is it the first question? No, our last question that Peter and I asked. How do we properly cost the CO2 contained in manufacturing our imported goods and products? And I think that is a massive issue, an enormous issue, where travel, of course, and transport of materials is crucial. But then, of course, we have to think in terms of the very diverse world we live in. One of the consequences of too many constraints of that sort might mean that some poorer economies that do depend on materials from elsewhere could suffer considerably. So it seems to me that's a big question, but a very complicated one. Now we're coming pretty much to the end of our time. Our anonymous attendee says a lot of this sounds a bit negative. Is anyone trying to put together a positive view of a low or no carbon future? I think that'll be necessary to achieve human behavioral change.
Well, I think Geoffrey and I should mention to you, we've been writing to the government several letters earlier on this year, saying that it's really essential that we have a proper roadmap, because what we've talked about is some of the options that are available, but we do need a roadmap, and we also need human behavioral change. And actually, while the government could produce a roadmap, it might be much more difficult to get human behavioral change, for people to give up their SUVs and have much lighter weight vehicles that are going to consume less energy, because we do have to have a reduction in energy demand, whereas up till now it's been a continuous increase in energy demand.
Well, let me have a go at anonymous attendee's question. I think that avoiding dire consequences is rather positive than rather negative. What we're trying to do is to ask the question, what do we need to avoid some of the serious consequences that might come from the way in which we humans use the planet? And to say, but to do that is complex, and it needs real engagement from governments, leadership from them. It needs engagement from scientists and researchers, and it needs involvement from citizens. It's a complicated issue, probably the biggest challenge that the human species has collectively faced. And I agree, once you put a positive spin on it, this is a battle we have to win. And then Norrie MacPhail, it's all about money, and we all know that. Oh, well, maybe. Peter, I think our time's almost up.
Yes, I think we should sign off now.
Yes. Do you want to make a valedictory comment?
No, I think we've tried to explain to you some of the issues as some of the options as we see them. So we hope you found that interesting. We hope we've given you some thought.
Thank you very much. And if I can add, before this program came on air, we had a brief conversation with some of our colleagues in the Royal Society offices, saying that it would be good, even if there is such a thing as a post-COVID period, to think of doing these sorts of things on a more regular basis with greater frequency, with more outreach to schools and the like. So for us, it's been a learning experience as well. And one might quote Winston Churchill saying, to say, never waste a good crisis. So thanks all very much. Your input's been valued and valuable.
And thank you very much for participating today.